Image captioning is one area where AI has evolved a lot. In this video, I'm going to show you how to do image captioning with this new model called as Kappa from VanDB. Before I show you the installation, let's have a quick overview of this model. Vision models are commonly used in diverse tasks: classification, segmentation, captioning, image generation, editing, and now even in LLMs for vision capabilities. These models are typically pre-trained either as classifiers using ImageNet or similar, or with contrastive techniques based on CLIP. These researchers have shown that we can train competitive vision models as image captioners on noisy datasets. It is an interesting alternative as captioning requires a detailed understanding of an image, so this model Kappa could lead to more powerful vision models. As I mentioned earlier, we are going to locally install this Kappa model, and we will also use an image to caption it. Before I show you the installation, let me give a huge thanks to Mast Compute who are sponsoring the VM, which is NVIDIA RTX A6000, and also this VM. If you are looking to rent a GPU on cheap prices, I will drop the link to their website and also a coupon code of 50% discount on range of GPUs. I will also drop the link to this Kappa website or blog, whatever you can say, in the video's description. Also, I will drop the link to the notebook which I'm going to use in the video's description. So don't worry about typing all the commands I'm going to use, and there will be a lot of them. So let's first install our Jupyter notebook after creating a Conda environment, and then we will get cracking with this model. Let me launch my terminal. As you can see, I'm running Ubuntu 22.04 and I have one GPU card of 48 GB VRAM. Let me clear the screen. Let me create a Conda environment where I will be installing everything. I'm just calling it Kappa and I'm also activating it. Let's wait for it to get activated. That's done. Let's me clear the screen, and now let's install our Jupyter notebook. Let's wait for it to get installed. And that is also done. Let me clear the screen. And now let's launch our Jupyter notebook. It is going to open it in the browser, as you can see. Let's wait for it to load. That's done. Let's click on File, New, and then New Notebook. Okay, so all is good and nice. Let's install some of the prerequisites. And I will be using JAX to get this model installed and then play around with it, among with some other prerequisites like flags, transformers, pillow, request, drawbacks, and that sort of stuff. I already have covered JAX on the channel, so if you are interested to know more about this clip JAX and JAX, so just please search the channel. You should be able to find a lot of stuff there. Let's wait for this thing to get installed. It will take around 2 to 3 minutes. And everything is installed, as you can see here. We are all good. Let's go down and download the model, which is already pre-trained, and that is the model from Hugging Face, which I'm downloading with Hugging Face CLI. And really huge shout out to the creator who has done a wonderful work with this captioning model. Let's wait for it to get downloaded. It is going to take a bit of a time. As you can see, it is loading it. Almost there, I guess. And if I just go up to see, yep, it's already done. That is all good. It's very quick today. And now let's import all of the libraries which we have installed. I'm just going to put it in this cell, and you can see that I'm just importing all the stuff which we have just downloaded, including some of the standard libraries, IO functool, and then few others. Okay, so it has, okay, so I just need to, it says there is no pillow, so we just need to convert it to pill. I always keep forgetting. It's a newer version, so that is fine. It should be good now. Yep, that's all good. Okay, so that is done. Now let's grab our tokenizer, because we also need tokenizer with the model to convert our prompt to tokens. Let's grab the tokenizer for this model. That is done fairly quick. And now let's specify our current working directory where we will be loading the model. So I'm just giving it config.json name and then creating that. So let's wait for it. So this is a whole configuration of the model, and these are all the parameters of the models. What is a pad token, pool type, layers, position embedding, and that sort of stuff. This is out of scope of this video, but I already have covered it in various other videos, but exactly these parameters about the model mean. And now let's load this model. That is also done. Let's initialize this model by using JAX, and as I mentioned, if you don't know what JAX is, please search the channel, and then you can ignore this warning for now. Now if you want to explore the parameters with JAX, all you need to do is to run this command, and that is going to give you the shape and lot of other stuff. Because just to give you a quick idea, JAX is it's just a software library that provides a flexible and composable way to transform Python plus NumPy code into wide range of platforms, include TPU, GPU, CPU. It gives you auto differentiation, automatic vectorization, and also, more importantly, just-in-time compilation. So pretty good library, to be honest. Anyway, so you see it has given you all the parameters. Again, if you're a machine learning engineer, you would know it, but if you just want to caption the image which we want, don't worry about it. I just wanted to show you that this is also possible. You can also get the model's checkpoints or weights. There you go. So we already have it here, so that is all good and nice. Let's restore it, which means I just put it on our GPU in simple words. Sorry, I just need to copy paste properly the commands I already have. There you go. So I'm just reloading it. You can ignore this warning easily. Okay, so now it is time to do the inference. For inference, all you need to do is to just create these functions. Again, as I mentioned earlier, JAX is this just-in-time compiler, and you just need to mention some of the required parameters like num underscore beams, then randomness of the response, some probabilities, top p, top k, and max length. And this num underscore beam is quite an interesting parameter. It is related to beam search, which is a heuristic search algorithm that is used to generate sequence of tokens such as words or characters in models. So that is why we have kept it here. It is we will be also passing it. So let's create these functions, and these are present on their GitHub repo, which you can readily use, and I will also give you the link, so don't worry about it. Now let's give it a image. We will open this image with the help of Pillow. Let me run it. There you go. So this is the image. Now let's caption it with the help of this model. And for captioning, we will pass the pixel values, parameters, and numbeam, which we already have. These params and pixel values we already specified above. And then for this beam search, we are passing it the 4. Let's wait for it to come back. And sometime it takes a bit of a time because it's the first time it loads it, and then it gives us the answer. So let's wait. And there you go. It has given us a caption as rabbit family, which is good. We can try, for example, if you want more than one, you can run this. Like num return sequence is 4, it is going to give you 4 captions. Let's wait for it to come back. And there we have 4 captions for this model. So very nice model, and you can see that this model, the Kappa, is trained as a captioner and mass prediction on large noisy image dataset. So it sort of represents an alternative to building vision models through classification or contrastive learning like CLIP. So I will drop the link to this in video description. Play around with it, let me know how you go. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network as it helps a lot. Thanks for watching.